What if I told you you could travel across the entire solar system, Earth to Mars, Jupiter, and beyond, by basically coasting downhill the whole way? It sounds like something straight out of science fiction, right? But it's not. It's a real network of gravitational pathways, a cosmic web of free rides that lets our spacecraft hitchhike across the void using like next to zero fuel. So, let's dive into this absolutely incredible concept, the Interplanetary Transport Network. For decades, our whole approach to space travel has been pretty blunt. We just point a rocket where we want to go and hit the gas. Really, really hard. It's this brute force method that guzzles an insane amount of super expensive, super heavy propellant. And honestly, that's been the single biggest roadblock to building a real, working economy in space. But what if there was a smarter way to get around? A more elegant way? And this slide just nails the difference between the two approaches. Okay, so on the left, that's the direct route. It's like flooring it on a road trip. You get there fast, sure, but you'll burn through your entire fuel tank. Then on the right, you've got the ITN route. This is the Interplanetary Superhighway. It's the scenic path, using the natural dips and curves of gravity to just coast along, sipping fuel like you're on a casual Sunday drive. But here's the crazy part. These pathways aren't like fixed roads on a map. No way. They're more like a dynamic river system, constantly shifting. As the planets orbit the sun, these gravitational currents change and flow. The whole idea was actually uncovered by scientists at Caltech and JPL back in the 90s, and it's all based on something called chaos theory. Now, that sounds complicated, but it just means that a tiny little gravitational nudge, the flap of a cosmic butterfly's wings, if you will, can send a spacecraft sailing on a massive journey across the solar system. So, how in the world does this actually work? We're about to get into the physics, but don't worry, you are not going to need a PhD for this. The best way to think about it is like we're playing a giant game of cosmic pinball. Let's look at how we can play the solar system to our advantage. So, the entire system is built on this principle called the three-body problem. It's this beautiful, complex dance that happens when you've got two massive objects, say the sun and the Earth, and one really tiny object like our spacecraft, all pulling on each other. And the way they interact create these really special points where all the gravitational forces just cancel each other out. Think of it like a celestial tug of war. You've got the sun and the Earth, two big kids pulling on a rope. Our little spacecraft can just stand right in the middle, where the pull from both sides is perfectly balanced. It can just hover there, using almost no energy, caught in this perfect gravitational sweet spot. And that, right there, is the secret sauce. Now, these special balance points have a name. They're called Lagrange points. And get this, they were figured out way back in the 1700s by a guy named Joseph Louis Lagrange. For us, you can think of them as the on-ramps, the off-ramps, and all the major interchanges of this interplanetary superhighway. They are the gateways that let a spacecraft slip from one gravitational pathway right onto another. And hey, this isn't just theory, we already use them. The L1 point right between the sun and Earth, that's a perfect spot for solar observatories like the SHO satellite. Then there's the L2 point just behind Earth, which is where we parked the incredible James Webb Space Telescope for a super stable, super cold view of deep space. And L4 and L5, they're like cosmic parking lots, so stable that entire swarms of asteroids, called Trojans, have been hanging out there for billions of years. And this is where it all clicks into place with our cosmic pinball analogy. So the planets are the bumpers, bouncing our spacecraft around. The Lagrange points, they're the flippers, giving us that crucial little nudge onto a brand new path. And the ITN pathways themselves are the grooves where the ball, our ship, can just roll smoothly right across the board without us having to constantly slam the buttons. Now, I know this might all sound like a beautiful theory, but here's the best part. It actually really works. We've been using these principles for decades, a lot of the time out of pure necessity, proving that this cosmic highway is very, very real and incredibly useful. I mean, just check out these comeback stories. In 1990, Japan's Hitten spacecraft lost its main engine on the way to the moon. Mission over, right? Nope. The engineers improvised this incredible, winding ITN route and managed to get it there anyway. Then you had NASA's Genesis mission, which used an L1 loop to collect solar wind on a tiny fuel budget, and the Artemis probes, which used these gravity tubes to hop over to the moon's Lagrange points. It's amazing stuff. Okay, so we've got this amazing, super fuel-efficient transport system. What's the killer app for it? What's the one industry that could be completely blown wide open by this technology? Well, the answer is asteroid mining. See, the biggest problem with mining asteroids has always been the absolutely staggering cost of launching heavy equipment. You need massive rockets just to escape Earth's gravity. But the ITN basically solves this. It allows us to slowly but cheaply send heavy mining depots and robotic freighters out to near-Earth asteroids. We're talking about turning a financially impossible idea into a totally viable business model. And it all comes down to this one single number: 90%. That is the estimated fuel savings you get by taking the scenic route. Just let that sink in for a second. For an industry where the number one cost is launching heavy stuff, a 90% discount on fuel isn't just an improvement, it's a full-blown revolution. But of course, there's no such thing as a free lunch, not even in space. The ITN lets you trade fuel for time. A direct, brute force trip to Mars might take 6 to 9 months. An ITN journey, that could take 2, maybe even 3 years. This is the central trade-off of the entire system. And yeah, that huge time commitment is just one of the challenges we're facing. Like any highway, the ITN has its own set of potholes and hazards that we need to learn how to navigate, and navigate very, very carefully. So, the biggest hurdle is speed, or, well, the lack of it. It's great for cargo, but for humans? A journey that takes years instead of months means you have to manage supplies, psychology, and radiation exposure for a much longer time. And on top of that, navigating these chaotic paths is unbelievably tricky. One tiny miscalculation, one little error, and you could send your multi-million-dollar spacecraft just spiraling off into the void. But the good news is we are getting so much better at taming this chaos. We're developing advanced AI that can literally make real-time course corrections on the fly. We're designing hybrid systems that use the ITN for the long haul, but have small, efficient thrusters for precise little maneuvers. We're even thinking about building depots at stable Lagrange points that could act like refueling stations. So let's put all of this together. If we can truly master the Interplanetary Transport Network, what kind of space economy could we actually build by the 2030s? What does that future look like? The vision is for a 2-tiered logistics system. Imagine slow, heavy cargo freighters, like robotic space barges, constantly moving resources like water and metals along these low-energy ITN routes. At the same time, humans would travel on separate, fast express lanes using more powerful and, yeah, more expensive rockets. It's basically the space equivalent of sea freight versus air travel. And look, this isn't some distant dream. This is happening now. NASA's Psyche mission, which is on its way to a metal-rich asteroid as we speak, is testing these very principles. And you can bet that commercial companies like SpaceX and asteroid mining startups like Astroforge are watching very, very closely, planning to use these exact routes to build their businesses in the next decade. All of this really leads to a fundamental shift in how we see our own cosmic neighborhood. For so long, we viewed vast distances of space as this huge barrier, something to be overcome with just raw power. But what if that's been the wrong way to look at it all along? And that brings us to the key takeaway, a quote from one of our sources that just perfectly captures this new way of thinking. The ITN shows the solar system isn't a barrier. It's an invitation to explore smartly. It's a connected web of pathways, just sitting there waiting for us to learn how to navigate it with elegance and efficiency, instead of just brute force. By learning to work with the gravity of the solar system instead of fighting against it, we unlock all the resources of the high frontier. The void isn't empty, it's an invitation. So what's next on our journey? Well, if you think hitchhiking on gravity is cool, just wait until you hear about kites that can sail across space, pushed only by the light of the sun. Join us next time when we explore solar sails.